In this video, we are going to explore what is the relation between gain, directivity, and radiation efficiency of an antenna. Consider a metallic patch antenna which is supported by a grounded dielectric. If we feed input power to that antenna, because of the conduction losses on these patches and the dielectric losses on these dielectric, some part of the power will be getting lost and only some part of the power will be getting radiated. So the part of the power getting radiated depends upon the conduction losses and the dielectric losses. So it is defined based on the radiation efficiency. Eta is equal to eta C into eta D, where eta C is the conduction efficiency and eta D is the dielectric efficiency. So PR will be less than Pin based on this radiation efficiency. So let's see what is meant by gain and directivity. So in case of the gain of the antenna, it is defined as the ratio of the intensity U in a given direction to the radiation intensity that would be obtained if the power accepted by the antenna, that is P in, were radiated isotropically. So this is the definition for the gain of the antenna. And in case of the directivity of the antenna, it is defined as the ratio of the radiation intensity in a particular direction to the radiation intensity all over the direction. So this is the relation for the directivity. You can see the difference in the definitions of gain and directivity. In case of the directivity, we are considering the radiated power. And in case of the gain, we are considering the total input power. So if we are considering the total input power, we are considering all these type of conduction losses and dielectric losses taken into consideration of calculating the gain, because we know that Pin will be more than the P radiated. So the gain of the antenna will be less than the directivity of the antenna, and it depends upon the conduction losses and the dielectric losses, or in terms of radiation efficiency. So we can say that gain of the antenna is related to the directivity of the antenna by radiation efficiency by this equation. Gain is equal to eta into D, where eta is the radiation efficiency of the antenna. And we know that this radiation efficiency depends upon the conduction and dielectric losses. So let's see in some of the example, if we have no dielectric losses, what will be the impact of the gain and the directivity. To understand the relations between the gain and directivity, I am going to consider a metallic horn antenna. Here you can see that it is a metallic horn antenna. So that means it does not have any dielectric losses. So we know that gain is related to the directivity by radiation efficiency. Radiation efficiency depends upon dielectric and conduction losses. So here there is no dielectric losses, and as it is made up of the metal, the conduction loss will also be very less. So let's see how it will be in case of directivity and gain. So here you can see that the directivity of the antenna is around 13.6 dBi, and if you look for the gain, you can see the gain is around 13.5 dBi. That means both gain and directivity are almost similar, because as there is no dielectric losses and the conduction loss is very less, as this antenna is purely metal. And let's consider a case of the antenna where it has both dielectric and patch. So this is an antenna which consists of metals, and it has both dielectric and metallic patches. So let's consider what will be the impact on the gain and directivity. So here you can see that the directivity of the antenna is around 7.49, and if I consider the gain of the antenna, you can see uh, there is some reduction of around zero point 0.7 dBi if we consider the gain of the antenna. So this reduction in gain with respect to the directivity is due to the conduction losses and the dielectric losses, because this antenna consists of both dielectric and the metals. So we have seen that in case of a metallic antenna, as there is no dielectric losses, gain and directivity will always be similar. And in case of these type of antennas, there may be some difference between gain and directivity due to this conduction and dielectric losses. So I hope you get some idea about what is the relation between gain, directivity, and the radiation efficiency, and how the conduction and dielectric losses will impact the gain. So if you find any of our videos useful, kindly support by liking, commenting, sharing, and subscribing. Thank you.